Hi guys, welcome back to 4B notes, writing a function rule or an equation. A rule and an equation are synonyms. So we're going to talk about how to write these function equations, and we're also going to talk about some special notation. So this phrase right here, y is a function of, or y depends on x, is what we talked about in the last couple of videos. We're going to translate that into a mathematical equation like this. We're going to say y, so here's the y, is means equals, and to translate the words a function of, we are going to use a small f, and we're going to put the x in parentheses next to it. This is how we're going to write y is a function of x. Now, it's important at this point for you to know that f is not a variable. Looks like a variable. It's a letter for sure, but basically we're using the first letter of the word function to stand for this particular character right here. So this says y, which is the output, the y-axis. Y depends on, or is a function of, the x variable, the input. So you'll get familiar with the way this looks, but this is the mathematical representation for, if we read it out loud, it would say y is f of x. So I'm generally, when I talk about it, I'm not going to say y is a function of x, because mathematicians like shortness and symbols and stuff to stand for big long words. So I'm going to say f of x instead of is a function of x. So normally when you're just writing math equations that don't really have any real world significance, we use y and we use x for our variables. But oftentimes, and certainly when you get into this in science, you're going to see other variables besides y and x. These variables are called intelligent variables. And that's generally because the first letter, the variable that you're using is the first letter of the word that it stands for in the real life word problem. So if you look example 1, it says the number of bacteria, capital B, and they give you this variable. You're not choosing it, they give it to you. Depends on, or in other words, is a function of time, little t. So if we look at this, B is the output. He's the output. And t is the independent variable, or the input. And if we were going to write this mathematically as a function, we would say B is a function of t, and it would look like that. Similarly, example 1b, the grade, little g, that you receive depends on, and this tells you the input and the output, so the grade depends on. The grade is the output, the effort is the input. So generally, the grade you get, generally speaking, is an output of the effort you put in. Little g, parentheses, E. And these are intelligent variable because G stands for grade and E stands for effort. All right, let's look at a couple scenarios in example number 2 where we're actually going to write a function rule, which is the title of this guy right here, function rule. Another word for function rule, shorter word, thank goodness, is equation. So we are going to write an equation based on the information that they give us in the word problem. So it says write an equation that represents the total amount of waste, W, after M amount of months. So we can't choose the variables. They've given us the variables. They are intelligent because W is the letter that waste begins with, and M is the letter that the word months begins with. So we need to figure out what's the independent variable and what's the dependent variable. So when you look at it, it says that the landfill that collects the waste in at an additional rate of 420 tons per month. So our output is going to be the waste being a function of the months that the garbage is accumulating. So the waste is a function of the months. The waste is the dependent variable. The months is the independent variable. And that is equal to the information in the problem. So let's see what we have. It starts at 5,000 tons of waste, and it accumulates 420 tons each month. So that's 420 times M, the number of months that this goes on. So there's our function rule, our equation, using the variables W and M. W is a function of the months, and we're using the information in the problem to set up the other side of the equal sign. Actually, I guess I could have written that down there. And then we can use our equation, our rule, to answer part B. How many months will it take for the amount of waste to surpass? There's your inequality right there. Surpass means greater than 10,000 tons. So we can use our rule and we can set it up and we can say, okay, 5,000 plus 420 times M, how many months will it be when that total is actually greater than 10,000? So we'll subtract 5,000 from both sides, and we get 420 M greater than 5,000. And when you divide, you get M greater than 11.9. So we can, generally speaking, we don't have to maybe take it to the 0.9. Usually when we're talking about months, we talk about whole months. So we can say about 12 months as our answer to answer the question. Okay, so that's it for this video. See you soon. Bye.